Well dear, we were designing circuits using the programming language 𝗟𝗶𝗸𝗲. 𝗟𝗶𝗸𝗲 is the most common programming language that is used to design electronic gadgets, and it's also used in the development of embedded systems. Well, you might wonder what an embedded system is. Well, the best example of an embedded system is here in your house. Yes, it's a washing machine. But we don't realize that a washing machine is an embedded system with hardware, software, and is used to design specific functions. In the previous session, we tried to turn the LED on and off using the text coding. It was simply amazing. So in today's session, let's try to make beautiful patterns for the LEDs using text coding. So dear, let's get on with our project. To begin with our design, let's add some more components to our previous circuits, that are LED blink circuits. Do you have any guesses? Yes dear, it's a push button switch. We need 3 push button switches for our project. So let's add them one by one to our workspace. Drag and drop the first push button switch from the component library. Click on the push button and name it to switch 1. Similarly, add the second push button and let's name it as switch 2. Then finally, add a third push button switch. Adjust it a little and name it as switch 3. Now dear, let's know more about a component which can easily have a lifetime which exceeds 50,000 hours. Can you guess the component? Yes, it's an LED. Oh my god! It's Mr. X. I think he has to convey something to us. Good quality LEDs can easily have a lifetime which exceeds 50,000 hours. And more councils are changing their street lights to LED versions for saving energy and increasing visibility. Thank you Mr. X, that was really useful. Now let's interface the push button switches to the Arduino. I hope you remember the terminals of a push button switch. Using green wire, connect the terminal 1B of the push button switch 1 to the digital pin D2. Then adjust the wire. Here an input is given to the digital pin D2 through the push button switch 1. Then let's connect the ground pin of the Arduino to the terminal 1A of the push button switch 1 through a resistor. Do you remember the purpose of a resistor in this circuit? Yes dear, if we connect our ground to pin 2 via a resistor, we can limit the large short circuit current and safely provide a load to our pin 2. So drag and drop a resistor from the component library and place it here. Then change the wire color to black and connect the ground pin of the Arduino to one end of the resistor. And from the other end, connect it to the terminal 1A of the push button switch 1. The pins 1A and 1B are internally connected, so the negative connection from the ground pin will reach the terminal 1B, and from here it will reach the digital pin D2. Then change the Y color to red and connect the 5V pin to the terminal 2A of the push button switch 1. Now, if we press the button, the high connected to 2A will be available at 1A as well as 1B as they are internally connected. And the current will not flow through the ground path because of the presence of a resistor. Because current always takes the path of least resistance. Similarly, let's connect the push button switch 2 and push button switch 3 to the Arduino. Let's zoom up our circuit a little for getting a good view. Change the Y color to blue and connect the 1B terminal of the second push button switch to digital pin D3. Then dear, adjust the connection. Drag and drop a resistor from the component library and place it here. Change the Y color to black and connect the ground pin of the Arduino to one end of the second resistor. And from the other end, connect it to the 1A terminal of the second push button switch. Then change the Y color to red and connect the 5V pin to the 2A terminal of the second push button switch. Similarly, let's connect the third push button switch. Change the Y color to pink and connect the 1B terminal of the third push button switch to the digital pin D4. Then adjust the connection. Then drag and drop a resistor from the component library and place it here. Change the Y color to black and connect the ground pin of the Arduino to one end of the third resistor. And from the other end, connect it to the 1A terminal of the third push button switch. Then adjust the Y connection a little. Now change the Y color to red and connect the 5V pin to the 2A terminal of the third push button switch. Then adjust the wire. So we have finished the connections. You can see that digital pins D6, D7, D8, D9, D11 and D12 are the output pins, and the digital pins D2, D3, D4 are the input pins. Now let's do text coding to turn these LEDs on by giving an input through the push button switch. Click on codes. You can see some codes are already present. In the previous session, we learned that in the void setup, we can define the analog and digital pins of the Arduino. That is, they can be set to input or output. And the codes to be run or executed will be written in the void loop. That is, if the digital pins of the Arduino has to be set to low or high, it will be written in the void loop. In addition to void loop and void setup, we need to initialize certain things. In the previous session, we learned to set a variable using the block coding. Similarly, let's learn to initialize variables using text coding. Go to line 1. Before starting, let's drag the circuit left and expand our code space. We need to initialize the variable just before the void setup. Let's use the syntax int and type int switch1 equal to 0 in line 1. Switch 1 in capital letters. And then don't forget to put a semicolon. Here we initialize the variable switch1 for the first switch. Similarly, let's initialize variables for the second and third switch. Just copy the syntax by pressing Ctrl+C, press Enter key and paste it here by pressing Ctrl+V. Then let's change it to switch 2. Similarly, press Enter and paste the syntax and change it to switch 3. Do you know the importance of this syntax? It means that initially switch 1, switch 2 and switch 3 are at 0. Press Enter to make space. Now let's describe the input and output pins at the void setup. So we have to define the digital pins 2, 3 and 4 as input pins. Let's write coding for that. For that, inside void setup, move to line 6 and press Enter. Then align the cursor. Then type the syntax pin mode within brackets 2, input. Make sure that the letter M in pin mode and input is in capital letters. Here we have defined the digital pin 2 as the input pin. After writing each code, make sure you put a semicolon. Now let's copy the syntax and press Enter. Then paste it here. Change the pin number to 3. Similarly, press Enter and paste it here one more time. And change the pin number to 4. We have defined digital pins 2, 3 and 4 as the input pins. We have already set D6, D7, D8, D9, D11 and D12 as the output pins in the previous circuits, that are LED blink circuits. Zoom out the circuit to see the connection completely. New function has to be written in the void loop. So erase the code inside the void loop. Now let's add new codes that are to be executed in the void loop. The digital pin D2 should read the input from push button switch 1, right? So type switch 1 equal to digital read within brackets 2. Make sure that the letter R in digital read is in capital letter and make sure you put a semicolon. Now the digital pin D3 should read the input from the push button switch 2 and digital pin D4 should read the input from the push button switch 3. For that, let's copy this syntax and paste it in the next line. Change the switch number to 2 and pin number to 3. Similarly, move to next line and paste the syntax one more time. Change the switch number to 3 and pin number to 4. In the previous session, we learned that if we want to check and execute a condition, we use if block, right? Similarly, here also we have some conditions to check. For that, we can use the syntax if. Condition 1. If switch 1 is pressed, the red LED should turn on and off. Then the blue LED should turn on and off. And then the green LED should turn on and off. Let's write the syntax for the condition 1. Move to next line and then type if within brackets switch 1 equal to high. Then open a curly bracket, move to the next line and type digital write within brackets 6, high. For the red LED to glow, the pin D6 has to be set to high. Now we need to set the pin D7 to low. For that, copy the syntax and move to the next line. Then paste it over here and change the pin number to 7 and type low. Now we have typed coding for red LED to turn on. Now add delay. So move to next line. Then type delay within brackets 1000. Now let's write coding to turn it off. For that, copy the syntax, move to the next line, then paste it. To turn the LED off, both the pins have to be set to low. So set pin 6 to low. We have typed coding to turn the red LED on and off. So now if the switch 1 is pressed, red LED turns on. Similarly, we need to turn on or off the blue and green LED. These syntaxes are common to turn the 3 LEDs on and off. So let's copy the entire syntax to turn the LED on and off and then paste it on the next line. We only have to change the pin numbers. The blue LED is connected to pins D8 and D9. So change the pin numbers to 8 and 9. Similarly, to turn on the green LED, paste the same syntax to turn the LED on or off in next line. Change the pin number to 11 and 12. After the if condition, we have opened a curly bracket. So let's close it as we have completed the syntaxes in this if condition. So move to the next line and close it. Click on Start Simulation and let's see the color pattern in which the LED turns on. Let's press the switch 1 and yes, we can see that. First, the red LED turns on and off. Then the blue LED turns on and off. And finally, the green LED turns on and off. These syntaxes will be executed only if we press the switch 1. And all the LED turns off when the switch 1 is off. Now click on Stop Simulation. Similarly, we can write coding for the second switch. For that, copy the entire code for the first switch and make space below the closed curly bracket for the first if condition. Then paste it and just scroll up the code. Condition 2. If switch 2 is pressed, the green LED should turn on, the blue LED should turn on, then the green LED should turn on. And then all these LEDs should turn off one by one. First green, then blue, finally red. Let's change switch 1 to switch 2. At first, we need to turn on the red LED, but we don't want to turn it off. So delete the syntax to turn the red LED off with delay. Select and delete line 47 to 49. Backspace to remove the space below. Then we need to turn on the blue LED and not turn it off. So delete the syntax to turn off the blue LED like we did before for the red LED. And then green LED turns on. Now we have to turn off all the LEDs. Move to next line. We already have the syntax to turn off the green LED. So copy the syntax to turn off the green LED and paste it below. Align the code line and scroll the code up. Change the pin number to 8 and 9 so that the blue LED turns off. Finally, move to next line and paste the syntax one more time. Change pin number to 6 and 7 to turn off the red LED. Scroll the code up. Click on Start Simulation. We can see that on pressing the second switch, the red LED turns on, the blue LED turns on, the green LED turns on, and then the green LED turns off, blue LED turns off, and finally the red LED turns off. Now dear, stop the simulation. Now you can add a color pattern for the LEDs when we press the switch 3. By changing the text codes, you can easily create any color pattern of your choice. Try out different color patterns by changing the pin numbers in the text codes. In today's session, we tried to make the LEDs blink and also make different beautiful patterns for the LEDs using text coding and also block coding. Well, that was really wonderful. In the next session, we are going to learn about a component which is very useful in our everyday life. So keep guessing it, dear. Until we meet again in the next session, bye!